What's going on, guys? In this video we are going to see how to prove this proposition using well ordering property. Okay, now here what we are going to do is we are going to prove the we are going to take the contradiction of this claim. This is our claim, because if we have if then statement, the one that comes after then is a claim. We are going to take the contradiction of this claim and prove that is wrong. If we can prove the contradiction is wrong, it means this is correct. The original statement is proved. Okay, that's what we are going to do. First we are going to let x belongs to the real number, because that's what is given. Suppose there exists an n belongs to natural number, n belongs to natural number such that x power n is less than 0. That's what this one, and 0 is less than or equal to x. This is contradiction, because here we have x is less than 0, here 0 is less than or equal to x. Okay, so let's go ahead and continue. So let s is equal to n belongs to natural number, x power n is less than 0. Okay, so by assumption we have the set is not equal to 0. By assumption S is not an empty, actually not equal to not an empty set. So by well ordering property, S has a smallest element, because if it's not an empty set, by well ordering property S has a smallest element. Here what we are going to do is we are going to take an element that's less than the smallest element, because if n is the we are going to name that one as n. Let's go ahead and continue. Let n be the smallest element of S. Let n be the smallest element of S. Here what we are going to do is we are going to take an element that's less than this, like n minus 1, and if we can prove the n minus 1, for n minus 1 also this condition applied, it means this is wrong, because we know that n is the smallest element, and if it's n minus 1, that is not in the set, and this is applying for that one, it means this the contradiction proposition is wrong. That automatically means the original proposition is correct. Okay, that's what we are going to do. Now let's go ahead and continue. Here we have let n be the smallest element of S. So since by this one we know that 0 is less than or equal to x power 1. I'm just copying this one. If it's just x, it means x power 1. So we can say 0 is less than or equal to x power 1, and 1 is not belongs to the set, so n is not equal to 1. Okay, n is not equal to 1. Therefore if n is not equal to 1, then n minus 1 also not be equal to 1. N minus 1 belongs to the natural number. Now n minus 1 also not belongs to the set, which implies that 0 is less than or equal to x power n minus 1. 0 is less than or equal to x power n minus 1. Okay, I just applied this one for n minus 1. Now we have this one, and then since 0 is less than or equal to x and 0 is less than or equal to x power n minus 1, we have, if we multiply both, we have 0 is less than or equal to x times x power n minus 1. Hence 0 is less than or equal to x power n. Okay, now let's go ahead and continue on top. Okay, let's continue here. This is a contradiction, since n belongs to the set. This is a contradiction because if you look at the contradiction statement, that's only for the set, and it should only happen to the x power n, because n is the minimum element, so it should happen to the x power n, and it's happening for the element that's not in the set, that's n minus 1, that is less than the minimum. So this is a contradiction, since n belongs to the set. Therefore we can say, therefore if there exists an n belongs to the natural number, x power n is less than 0, then x is less than 0. Therefore for all x belongs to the real number, if there exists an n belongs to the natural number and x power n is less than 0, then x is less than 0. That's what we want to prove, because that's the original statement. We proved this one, therefore this proposition is proved. I hope this helps. Thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.